Hey everyone, welcome to the webinar. In this session today, we have invited Dr. Saurabh San to share his knowledge on how businesses derive value from data science. He has been uh, an expert and experienced professional in this field for a while now, and with us, he has been training industry professionals into the same skill set and comes with a both of a researcher and academician perspective. I think there is a lot of knowledge to derive from him. Over to you, Dr. Sorab. If you could start with a brief introduction about yourself and then what today's session is going to be about. I think that will be helpful for everyone attending.
Thank you.
Am I audible? Okay.
Yeah. So let me share my screen. Is my screen visible?
It is. It is. We can see your screen.
All right. Okay. Good morning, everybody. I'll briefly introduce myself. I am Dr. Shohra Hossein Sheikh. Currently, I'm working as an associate professor in one of the universities in Gurgaon. I'm also a certified data scientist, uh, and my research area is computer vision. I also teach students in this domain of AI, data science, machine learning, and deep learning. I have been associated with Edvancer for a couple of years now, and I have taught many of their AI and deep learning module. Um, and today I'll talk about data science. To be specific, I'll start with some basics of data science, and finally, I would like to talk about how data science is being utilized to derive business values. I'll be showing you some of the use cases. So right now, how many attendees we have? 25, I guess, right? I'm not able to see their names, but anyway, I hope that you are coming from very diverse background, and that's why I'll keep this particular session very generic so that it will be applicable to the larger audience. But at the same time, I would like to be this session should be interactive. So any point of time, if you have any queries, you can please unmute yourself. I hope that access is given to the participants, and you can talk, or maybe you can write something, any queries, any questions in the chat window. So this is how I'm planning to hold today's session. We'll start with an understanding of what is data science, and what is a typical data science pipeline, what are the different tasks we do there, and how this data science is related with machine learning algorithms. And nowadays, we keep talking about artificial intelligence, machine learning, deep learning. So how this connection of data science with these other technologies that we have. So that is something we have to bridge this gap, so that whoever is actually looking for building a career in data science will have a clear idea about what data science is and what are the different skills they have to acquire to be a successful data scientist. And before going to the specific use cases, I'll also talk about what are the major driving forces behind the success of data science, AI, machine learning nowadays. I'll also talk about what are the recent trends. So if we talk about in terms of what people are looking for, what type of skill set people are looking for, then what is the general trends all over the world, and what is the trend in India especially. And then I'll talk about those use cases. So I have taken some examples from banking, some retail use cases, and some manufacturing, especially in this domain of predictive maintenance and healthcare. So let's start with what is data science. I hope that more or less everybody has some idea about what is data science, but let me define it the way I like to say it. So probably many of you have already seen this kind of a diagram, or if we talk about what is data science, basically we talk about a multidisciplinary field where we need knowledge from mathematics, statistics. We also need knowledge from computer science and IT, because we have to talk about algorithms. We have to talk about different machine learning models, and machine learning is a very old field, just like statistics. And now that we are actually using it for generating many interesting solutions, many interesting business problems, and that's why this is basically becoming so popular nowadays. But apart from that knowledge of maths and statistics and computer science domain, we also need this domain knowledge, right? Which is business knowledge or domain knowledge, which is extremely important. So if we look at this particular picture, you see that data science or data scientist is actually sitting on the overlap of these particular three fields. We need some business knowledge. Uh, Whatever problem we are solving with data science, machine learning, uh, data scientist has to have a particular business knowledge in that particular domain. Okay, and if let's say normally what happens in the industries here is that doesn't matter what type of problem you are actually solving with data science, you basically work as a team. And if the data scientist doesn't have in-depth domain knowledge, then there must be a group member who is expert in that particular domain. So basically, we are not talking about a single person is working. Rather, there is a team of a team of more than one people who are actually talking about and actually building a successful data science team. So we need domain knowledge to understand what is the business problem I'm trying to solve, and then you have to think about what kind of statistical or mathematical model, uh, what kind of machine learning models would be useful to solve that problem. And then when we actually try to write some computer programs, we actually need this understanding of computer science, software development, machine learning models, how to use them, what are the software packages, libraries are available there to make our life easier. Okay, so in short then data science is basically a multidisciplinary field that uses scientific methods. Here you see that the name science appears in this data science name, right? So science means we are basically talking about some scientific methods. Okay, so whenever you have some research problem, for example, or a business question, there is a typical scientific method through which we actually pass to prove that particular hypothesis. Okay, so if these terms are you are not so familiar with hypothesis and all these things, don't bother about it. Just be satisfied with this definition that this is basically a multidisciplinary field where we are basically following certain number of steps. What are those steps? I'm going to explain in my subsequent slides. And what is our objective? We want to build some computational models or algorithms using computing systems, and our ultimate objective is to extract knowledge and insight uh, from whatever in whatever form we are getting the data, right? It could be structured format, it could be unstructured format, but data contains some hidden knowledge, hidden patterns, and that is something which we want to extract through this process of data science. And ultimately our objective is to generate some insight. So after analyzing data, we'll be generating some insight which will help the business leaders to take better business decisions. So that's why this knowledge of business or domain knowledge, mathematics, statistics, and computer science development, everything comes into the single picture. So this is about a rough idea about what is data science. And if we think how this data science is related with this notion of artificial intelligence, machine learning, or deep learning. So that picture will be somewhat similar to this. So I'm zooming in on the left side, coming to this picture now. So we see that artificial intelligence is something like an umbrella term. Okay, and there are many things comes under this umbrella. Okay? I have actually specified some of them, but this domain is extremely complex, and there are our real AI comprises of something more than traditional machine learning or deep learning that we talk about today now. It starts with logic, uh, proposition, inference, reasoning, and lots of other things. Okay, so in this case, you can think that artificial intelligence is something like the broad umbrella, or you can think that if this diagram is representing some sort of set and subset type of relationship, so that's actually the superset. Okay, and within this artificial intelligence umbrella, we have a part which is called machine learning. Okay, and a type of machine learning which deals with very deep neural network, artificial neural network, that is actually called deep learning. Okay, so you can think that deep learning is also machine learning, but we are talking about some very complex, uh, uh, you know, complex computational models. Okay, now if we try to understand what is the relationship between data science and all these three fields, we'll see that data science is something like an overlap with all three, right? So we see that data science basically means a math, statistics, statistical technique that I have referred to in my last slide also. Okay, and then data science may use uh, some conventional machine learning approaches, right? What are those algorithms? I'll talk about in my subsequent slides. And if required, if we have huge amounts of data available, and if our conventional machine learning model is not giving us the accuracy that we are looking for, then we can also use deep learning techniques for that. Okay, so this is only one part of this entire story, right? So this is basically our model building part. Okay, we tend to build some computational models that will extract some meaningful information from the data. And for making that model, I can use conventional machine learning, or I can use deep learning, depending on availability of data, what kind of accuracy you want, and the degree of complexity between my input feature and my output levels. Okay. But in most of the business use cases, it has been found that very successful data science models are not so complicated models. Okay, and then our conventional machine learning models actually performs very good there. Okay, unless we are talking about very large systems, like for example, uh, if we are talking about the voice search, technique in Google, for example. Okay, they have collected lots of amount of data, and they have trained a very deep neural network uh, to make this successful. All right, so then when you talk about building the computational model, then we see that there is a overlap between data science and machine learning or deep learning. But apart from that, we want to extract some meaningful information, and sometimes visualizing that information in the form of some chart or plot, or performing some exploratory data analysis, trying to understand the data better. Those are the common tasks that we perform in data science. Okay, so that's why we see that there is this particular yellow blob is actually showing you that apart from that overlap, there is something which involves purely mathematical or statistical techniques. Okay. The other point I would like to mention here is that sometimes we also talk about big data. So what I want to mention here is that these fields are actually overlapping with each other. I mean, if we can think about a data source which is not big, then typically you are performing data science operations there. But let's say my data source is very big. We have collected huge volume of data, and I want to extract some meaningful, insight from that from that data, right? So then we'll perform our conventional data science steps on that big data. Okay, and here we see that all these steps we are showing at the uh, upper side of this particular slide. We see that we are performing different data science. We are applying analytics, we are applying business intelligence, we are applying statistical technique, different visualization technique to understand this data better. And in the process of this, we are applying machine learning or deep learning that enables, some data mining processes, extract meaningful pattern from our data. Okay, and in that process, our deep learning or deep neural network is actually facilitating these operations, right? So normally, when we talk about AI, we are basically trying to simulate human intelligence. Okay, and that human intelligence is actually exhibited through our vision system, what you see in front of your eyes. So the way a human actually interprets whatever he is seeing in front of his eyes, can a computer also do that? So that is actually a part of what we call as computer vision. This computer vision is my research area, which talks about what the computer sees, whether it is able to interpret it. Okay. Natural language processing is another intelligent task. We speak certain language, somebody is talking to me in certain language, I'm able to understand it, right? And I'm able to give him some meaningful reply. Okay, so that reply will not be meaningful if I'm not able to understand what the other person is saying. Okay, so therefore NLP is a big part of uh, approaching our actual intelligence. Okay, and there are generative models, and there are lots of other things falling under this umbrella. But the point I want to make here is that when we are saying that there is some data available to us, and we want to extract some meaningful pattern so that I can take better decisions, right? So this kind of data-driven technologies, digital technologies, is not actually working in silos, right? So we see that later I'll show you some examples of IoTs also. We'll see that all these are actually um, facilitating collection of data at the same time, how we can extract some insight from the data through this process of data science. Hope that this is understandable till this point. If you have any queries, you may please write it in the chat window. I'm moving to the next slide, which talks about our typical data science pipeline. So normally, we collect data first. An organization collects lots of data, lots of business data, for example, and then we start with a question, right? So what is the problem we want to solve? So that business question is very important. Okay, and that's why uh, understanding the domain is very important, because I can ask some question, but maybe my data is not supporting to get that answer. Okay, then I have to ask a different type of questions, or maybe I have to collect more data. Okay, so therefore it's very important that depending on my business knowledge, I'll be able to understand that okay, whatever data I have collected from my customers, and whatever question I'm asking now, whether that could be revealed to this particular question or not. Okay, so there are typically there are different processes. So first of all, first step is called data acquisition. Then we do some sort of data pre-processing. Then we call it data wrangling. We call it data cleaning. There might be certain parts. Some features are not important. We can actually discard them. Some features might be missing. Then we can actually regenerate those features through feature engineering. We can perform some exploratory data analysis to look at a particular feature is there, and then can perform some statistical analysis and try to understand what is the mean or what is the spread of this particular feature. Okay, and then you can understand that whether this particular feature is important or not. So if it is not important, then you can discard it. Okay, so lots of pre-processing steps are there, and only then we reach a point when we can actually build a model. So we'll see that this model building step, uh, and this is basically a cycle to see here, right? So exploration, after a certain number of data exploration and cleaning and pre-processing, we are building the model, and this model building part is where our machine learning is actually helping us. Okay, so normally our conventional machine learning will be applicable there. Otherwise, if we have huge volume of data and we are not satisfied with the performance of conventional machine learning, then we can apply deep learning. This model building, after building these particular machine learning models, we can validate that model with our test data. If you are not satisfied, then we can actually go through this particular cycle of again building that model and then revalidate it until it's satisfied. Okay. And after all these things, what we're getting is that, we're getting better insight. So whatever data we have collected, that was something like, not so, like little bit of haphazard. We are not able to perform some X to Y relationship. But now I know that, okay, my customer is purchasing this particular product. So maybe there is a possibility that he will like some other products. Okay. So this kind of insight we'll get at the end. And that we can actually, storytelling is another important part. Uh, if I talk about the job description of a data scientist, so what is the insight you are getting after so much operations? Okay, so you have to tell this in the form of some maybe charts, visualizations, right? Whatever your stakeholders are expecting you to do, and then that will actually have some actionable insights. The actionable insight means when you will tell the business owner that, okay, this should be your way out. You have done this, but that should be done to generate better business revenue, right? So that's basically the actionable insight. Somebody knows that what kind of business decisions has to be taken to make it the reality. Okay, so this is the typical data science pipeline. But some of you might have come from some IT background, and you see that there are some pieces are missing. Probably you are not able to relate it. So I have another diagram, two diagrams actually, just to have a better understanding of what is going on. Okay, so we'll start with some business understanding, and this for business understanding I need the domain expert. Okay, then the next step will be data acquisition and understanding. Okay, you can data could be acquired from different data sources, right? I'm not explaining each one of them. And then after we have already acquired the data, we have to do those pre-processing, cleaning, data wrangling. All these operations will be done, right? After that, the model will be built, and this model building is basically where machine learning is coming into the picture. Okay, so after you build the model, you have to first, train the model with our training data. Before training it, you have to do some feature engineering. Then after training, and then after your model is trained, then you have to validate this model, evaluate this model on test data. Okay, so those are the typical steps in every machine learning model building process. Now, when you are satisfied with the performance of the model, it may happen that you are not satisfied, for example. Then again, you have to go back. You see, there's all these arrows are actually double-sided, right? That means that probably you are not able to answer the query that you have asked at the beginning. Okay, so then you have to go back. You have to collect more data. Maybe you have missed collecting some important feature. Maybe let's say I'm collecting some information from the customers, but I forgot to collect the age information of the customer. What is the age group? And that age group might be a very important aspect to answer your business query. Okay, so you'll go back, we'll collect more data, and now my model is getting that particular age information, and therefore it will be able to predict a better predictions, right? So therefore now you'll be satisfied with the model, and the last step is that you'll be deploying this model. So there are all these models, for example, Google search, for example, whatever you are typing or through voice, whatever you are searching there, at the back end there is a machine learning model which learns and then which modifies itself, and this model is already deployed in the cloud. Okay, so after you build a model, now you have to deploy this model, and after deploying this model, basically there are two parts then. So one is development phase, and another is how we actually deploy and how these operations things are going on. Sometimes for some of you will be able to relate it with this particular picture that I'm showing you now. Okay, so from raw data to different data pre-processing, cleaning operations, data preparation, those are basically called some data engineering steps. Okay, because in this domain you will find different job roles like data scientist, data engineer, machine learning engineer, data analyst, right, business analyst, all these different job roles are there in this particular domain. So all these data engineering steps, and then this middle box is basically my machine learning models. We are building the model, validating the model. Once that is done, then you are sending this pre-trained model to our deployment team, right? So that means our DevOps team who are actually deploying this model in in the deployment environment. Okay, so the environment of the where we are actually developing this machine learning model, that is called the development environment, and then that already developed model is passed to the operation guys who actually deploy it on some cloud or on premise, depending on what type of solutions they are looking for. Okay, and after that, we can have some visualization. Now, after deployment, my model is actually running on real-time data, right? So, and then I can actually have some, performance analysis. I hope that this till this point, this is making sense. If there's any query, please let me know. So, is there any chat window where somebody can write what's
Right,
not
Dr.
visible
Sarab.
here?
If you look at chat window towards the bottom, you might have to uncollapse that.
Okay,
Yeah. There is
all
one
right. Okay,
question
let
coming
me see.
from Anju.
Yeah. So, okay, just give me a minute, please. Uh, okay. Is there any question here? Um, okay. So I'm from arts background. Can I join data science? Uh, uh, yeah. Um, Anu, we'll have a Q&A session towards the end where Pradeep will talk about what are the different courses Edvancer is offering to upskill professionals like you, or maybe freshers like any students who is graduating. We'll talk about this. So now just one line answer to your query should be uh, I have seen many people who are not from science backgrounds, right? They are also becoming successful data scientists. Okay, so door is open to all actually, right? As long as you are interested to learn, you are interested to upskill yourself, nobody is stopping you. Okay, but towards the end, we might have a better answer and how Edvancer can help you achieve what you want to achieve. Right? We'll have a discussion on that. All right, so I'll keep a look at this particular window. Okay, fine. So I'll move ahead. Um, Now, we have understood that where in this entire data science pipeline, we are going to use these machine learning algorithms. So here, I'm broadly tried to, categorize it into what are the different types of algorithms we have, right? So broadly, there are three types of algorithm we talk about: supervised learning, unsupervised learning, and reinforcement learning. So mostly, in today's talk also, we'll basically focus on supervised and unsupervised, even though I'm not talking about any specific algorithm today, but I'll try to relate it with the specific use cases, okay? And then we are not talking about reinforcement, but if we talk about real AI, then probably, unsupervised and reinforcement learning is more close to our real AI, even though right now supervised learning is actually dominating this entire space, okay, and they have been very successful. So here we have supervised learning can also be broken down into two subcategories depending on what type of problem we are solving. So one type of it would be classification problems. For example, let's say if I want to predict whether this customer will churn or not, okay, whether the customer will be retained or he will actually churn, okay. So then we are basically making a binary decision, okay, customer churns or customer doesn't churn, okay. Or we can ask a different type of questions, like for example, let's say what will be the selling price of this particular product, okay. So when we have something like um, categorical output like yes, no, or three different classes, four different classes, what will be the output? Then those are actually classification problems. Okay. But when I am basically talking about a real valued output, right? Real valued numeric output. So then that is actually a regression problem. So what will be the selling price of that product is basically a regression problem. Okay. Or maybe if I give you one more example, let's say I'm talking about classifying medical images, okay, whether looking at the medical image, let's say tumor, and then I want to predict what is the severity level. Okay, so early stage, mid stage, or severe. Three categories are there. So that's actually an example of classification problem. Whereas regression problem will be something like what will be the selling price of this particular car. Okay. Uh, when you talk about but supervised learning is very successful, but in this case we need to have some input and output pair. Okay, so if my data is not available in that form, if I don't know for this particular input this is the particular output I'm expecting, x to y relationship is not known, then we cannot apply supervised learning. Okay, so then there are many algorithms which are unsupervised in nature. So when we don't know this x and y relationship, y is not available, then we actually apply this kind of unsupervised techniques. And there are different approaches to this. Some techniques are called clustering techniques, some techniques are used to reduce dimensionality of the of a feature vectors and so on. And one such example could be, for example, given the customers of a retail shop, can I segment those customers into multiple, groups? Okay, and this is a typical clustering problem. Okay, so just by looking at the features of my customers, maybe their age, their buying pattern, how much money they're spending, depending on that, in an unsupervised way, we're going to group them into different groups. Okay, so that is an example of clustering. So reinforcement learning, or there are other examples. We are not talking about this. There are Q learning, different techniques are there. I'll not talk about this today. So typically, in data science, we are basically applying these supervised learning algorithms and unsupervised learning algorithms most often. Okay, and these are basically the names of certain algorithms. Okay? Naive Bayes, decision tree, support vector machine, k nearest neighbor, some classification algorithms. Similarly, for solving a regression problem, we have linear regression model. Neural network actually can solve both classification or regression problems, and there are decision tree. Both that can also support vector machines can also solve regression problems. Similarly, for clustering, we have k-means is very popular. There are different types of Gaussian mixture model based, or maybe mean shaped clustering, or there are lots of other algorithms. And here, we are trying to relate it with the type of problem that we are solving. Okay, I would like all of you to just try to remember it as much as possible. I'm completely ignoring this reinforcement learning for today. Okay? And let us focus on our supervised and unsupervised part of it. Okay, so let's see what we're doing here. So in the supervised learning, we might have some classification problem at our hand. Okay, so given some identity fraud detection, for example. Okay, so when there is some online transaction going on, for example, so I have to identify that I'm the legitimate person who is supposed to make this particular transaction. Okay, so then somebody, some hacker may actually interfere and then actually take control over the transaction. Okay, so whether the person is actually a legitimate user or not. Okay, so something like classifying different categories, or maybe image classification. Given an image, what type of image it is, cat versus dog, or some other thing. Or maybe customer retention. I have just now mentioned it, right? Whether the customer will churn or customer will be retained, right? So those are actually typical example of use cases of supervised learning. Similarly, for regression, we are maybe weather forecasting or market forecasting. All these are actually giving me some numeric output. Therefore, those are actually regression problems. And in the unsupervised domain, you see that we have something like um, dimensionality reduction. So we can compress our data with dimensionality reduction. Okay, or maybe most prominent examples of clusterings could be our targeted marketing. Okay, and customer segmentation. I'll talk about all this in my subsequent slides. So I'll not spend much time on this slide. I'll move to my other slides. I hope that I'll be able to complete in time. Okay, because last half an hour or so, I want to keep for Edvancer to talk about their programs and also some time for Q&A. And if I talk about what are the data analytics tools, you should be knowing. So as I told you that you need some business knowledge to ask the proper questions that will actually help the business take better decisions, right? So asking right kind of questions requires that somebody will know the corresponding business for a long time. Okay. If I talk about what are the tools, right? So for data acquisition, if you are talking about web scraping and collecting data from the internet, Beautiful Soup is one such, library which is available. We can collect this data, we can actually analyze, store this data. So we have this, Python, NumPy is one such library for numeric computation. Pandas, used for, both data storage and for data, exploratory data analysis. Okay, or you can also store structured data in a database like MySQL, for example. And for data wrangling, we have these, files, again, you're storing this data from CSV, taking it, NumPy, Pandas, SciPy for scientific computing, any kind of scientific computation. You can use this SciPy library. For data exploration, mostly, we use Pandas. For data visualization, we use Matplotlib, uh, Seaborn, this kind of library is there. And you are, basically, after all this pre-processing, there should be some machine learning model which will learn the meaningful pattern from your data. So therefore, for model building, scikit-learn is a very popular library in Python to make your create your machine learning models in just 3-4 lines of code. Extremely easy to use. And finally, after you have found the hidden patterns, now you have to present it, you have to communicate it to some data visualization chart, plots, and so on. So then again, you can use Matplotlib, other tools, including Pandas. So what are the common data science deliverables? I've already given you lots of such examples. Very quickly, maybe I'll also talk about it. Some prediction, regression values, right? Classification, maybe some messages there, whether it's spam or not spam, right? Some recommendation is another example. So it could be some product recommendation by Amazon. So you're purchasing one product, Amazon is actually giving you recommendation for some similar products. Okay, or in Netflix, movie recommendations based on your previous, watch history. Netflix will actually recommend you some new movies. Okay? All those are examples of recommendation systems. Pattern detection and grouping, something like clustering example, customer segmentation, anomaly detection, like fraud detection, whether this particular critical transaction is a you know is a fraudulent transaction or not. So anomaly, some sort of anomaly should be there in the user behavior. Or maybe this any kind of recognition task. It could be through image, through text, through audio, video, facial recognition, and so on. And we basically want to achieve these actionable insights. Okay, so they're through any dashboard, report, visualization chart. Uh, we have to start our storytelling process. And our ultimate goal here is that our AI um, is about automating everything, right? So whatever a human being is capable of doing, my computer will also be able to do that. Okay, so any kind of automation is actually our end goal. Okay, and not only just automation, we want to make better decisions. So this decision making capability is another goal. Sometimes we also use this, data science or machine learning models for some sort of, ranking or scoring. Like for example, the credit score of a customer. Okay? That's actually called Pico score, or any kind of, segmentation based on the demographic information of the customers. Okay, or any kind of optimization, like risk modeling. I'll talk about it in a moment. And forecast, any kind of sales forecast or revenue forecast, and so on. Okay, so before I go to those particular use cases, I would like to mention that what are the major driving forces behind this recent boom in data science. Okay, so even though I say this recent boom, but this is not so recent. I'm talking about last 8 to 10 years, for example. Okay, but businesses were there, right? the question is important because businesses were there, industries were there for more than 100 years, right? So we have been collecting lots of data, right? But then what is the reason that, in past 8 to 10 years, we see that there is a sudden increase in the requirement of data scientists, right? And people are talking about data science, artificial intelligence, machine learning. What is the reason behind that? So what are the major driving forces? So in my opinion, there are three things which is actually playing the major role here. The first thing is the digitization of this entire society. Okay, think that we have been collecting lots of data, but that data is not readily available for a computer to work on, right? We have collected data, we have created our handwritten ledger, maybe, right? But we have not digitized it, right? But unless you digitize your data, your computer cannot work on it. Okay, so even though we have statistical model for a long time, history of statistics, past 70 years, right? But now, linear regression, these models are not new, right? It is it is there for years, right? But now we come to know about these terms very frequently, and this is the reason that we are able to digitize our society. Think about your smartphone, your smart band, CCTV, IoT sensors. They're collecting this data, continuously. Huge volume of data. So now that data is available to us, and then we think that okay, let us now data is available, so let us build computational models to extract information from that data. Something we don't know, which is not readily available in front of our eyes, we'll be able to extract that insight after doing this kind of processing. Okay, so this is the first reason. The other reasons are the following. One of the problems we had for a long time here is that if we have huge volume of data, we need computational power to run our algorithms. Okay, and in past 8 to 10 years, we have seen that a significant improvement uh, in this computing hardware which is available now. Okay, in terms of maybe the high performance computer, or maybe high performance GPUs, which actually uses multiple cores to perform massively parallel processing is possible now. Okay, so that reduces training time for our machine learning and deep learning models. Okay, at the same time, now cloud platforms are available. So for example, if I want to buy a computer with very sophisticated GPU, that will cost me over lakhs. Okay, maybe 2-3 lakhs I have to spend on purchasing a single computer. But now, cloud platforms, I can, instead of doing that, instead of investing so much money, what I can do, I can subscribe to a cloud platform, and they will be actually, having all those hardware, software available to them. I can use it, and I can pay as I use, right? So very, cheap schemes are there. If I use for 1 hour, this is the amount of money that I have to pay. So I don't have to, uh, waste my money, so much amount of money on purchasing that particular computer. Okay, so there's increase in computational power, and availability of computational power through cloud is another reason why this field is actually becoming very successful nowadays. And the third reason is our algorithmic innovations, right? So here I have mentioned some specific cases like rectified linear unit for artificial neural network, batch normalization, reparameterization tricks. All these things probably not making sense to most of you, but doesn't matter. There are some new algorithms which have been generated, which is actually uh, made this training of this model very easy now. Okay, means we don't have to spend a long time to converge, right? We'll be able to train our deep learning or machine learning models very fast. Okay, due to these algorithmic innovations. Okay, so these are the three reasons I believe uh, is actually driving the success of data science nowadays. And before going to these use cases, I would like to talk about this recent trends. So this is actually a Google trend search that I have done yesterday evening, and this is actually the global trend. And I have searched it with these 5 keywords: data science, machine learning, deep learning, artificial intelligence, and Internet of Things. I thought that Internet of Things is now also booming, right? So therefore, let's do a Google trend search on that. And this is actually the plot I have received. And this is basically a web search. We can select subcategories from here. But I select all categories, and we are basically looking at what is the web search, considering these global trends. That means worldwide, what is the trend? And starting from 2004 to 2022, we are now. So this is the trend that we are observing. Okay. We see that right after initially downward, then it flattens, right, and then after July to 2016, we see that there is sudden upward trend uh, in the demand of data science. So this is basically people are searching for data science, machine learning related resources, articles, on Google platform. Okay, and it clearly shows that uh, everybody is trying to understand what is the value in um, data science, machine learning. Learning these skills is important, and this is something like you are becoming future ready, future proof, and this is clearly exhibited in this particular uh, trends that I have found in Google Trends yesterday. If I want to talk about what is the trend in India now, right? So then I have searched it for the past 5 years, again with the same keywords. And here also we see that again, machine learning and data science is something people are actually looking for, and they want to build their career in this particular domain, and to become successful, and become relevant. Becoming relevant is very important. So you have to become relevant. So therefore, you have to upskill yourself, and you have to learn the technologies, which is the technology of the future. Okay, and clearly, your competency in this domain of data science, machine learning will actually help you um, achieve that. All right, so now I'll talk about these use cases, but I'll pause for a minute maybe, and I'd like to take I'd like to invite some questions if you have any. Um, I think there is one question. Shoptarshi is asking. I still fail to understand what big data actually is. The reference to the picture. Okay. So today my talk is not around big data. Big data means huge volume of data, and there are typical characteristics of big data also. What I wanted to mean here is that um, the objective of data science is to leverage the data that you have, right? So if you have um, some data which is small amount of data, if I say, we can perform data science on that, right? But if you are able to collect huge volume of data of petabyte or terabyte order, okay, then that data now becomes big, okay, and we can also perform data science operations on big data if required, okay. And now that we are talking about IoT sensors, which is collecting data every second, right? In fact, in a second we are getting multiple data points. So if you think about any temperature sensor which is continuously monitoring the temperature of a room, is collecting huge amount of data every day, right? So eventually our data will become big, okay, and then we need to resolve those problems. Conventional machine learning may fail there, conventional tools may fail there. We have to use our big data tools like Hadoop, MapReduce techniques, and those related tools to build sophisticated computational models. Any other queries before I talk about those business use cases? I hope that it's understandable, right? So I'll continue. Okay. So the first use case is something related to banking. Banking, how we are using this data science. Okay. So in the top right corner, I have written many things. I'll not talk about each one of them. I'll touch upon some of them. Okay. So let's see. So this customer segmentation is one, which not only banking sectors. Um, every company is now actually trying to segment their customers based on their behavior. okay, based on their behavioral segmentation, or maybe depending on the demographic information of the customer. What is the age group? What is the spending amount, or maybe what is the income of that customer? If I have that information, right? So based on that, they are actually segmenting their customers into multiple groups, so that their objective here is that if we can actually have something like targeted advertising or marketing for those customers. For example, somebody, let's say, fresh graduate who has recently you know had a job, right? Recently entered a job, and then probably will start spending money now, right? And his purchase behavior will be something different from a middle-aged person, who is actually having family, different types of liabilities. Okay, so if we can actually look at those profiles of those customers, we can also, bank has access to their customer accounts also. We can actually look at how much what is the how much money they're actually depositing or they're spending each month, right? And what is their account balance, whether they're able to maintain their account balance, steady account balance for a long time. So then those are basically the behavioral or demographic traits that you're talking about. So based on that, they actually provide some targeted advertising or targeted marketing to them. So somebody who is middle-aged, has a family, maybe bank will actually tell them that, okay, you can opt for some health insurance or medical insurance, for example. Okay, because bank is not only about depositing your money or transactions. Uh, there are different types of financial instruments, including insurance policies and so on. So therefore, if we are applying machine learning algorithms to have those different demographic of those customers, and we are able to segment them, okay, then um, then our targeted marketing will be much more easier and effective, rather than doing it blindly. The customer care team will call everybody and will offer a product which or service which is not relevant for that person. Okay, so therefore our machine learning models are actually doing this customer segmentation, and then much better personalized recommendations are actually now possible after this. The other use case for these banks is this risk modeling is extremely important um, business use case from the banking sector. Okay, and here very successfully we are using machine learning models. Okay, so when it comes to risk modeling, normally we talk about two types of risk. One is the credit risk, other is the investment risk. Okay, so credit risk means, let's say a customer is going to the bank to ask for a personal loan or maybe a house building loan. Okay, there are machine learning models which actually analyze this customer's data. Maybe it's credit risk, account balance, whether he has taken loan earlier, what is the repayment history, or normally, we talk about credit score for it. For now, more often, we talk about credit score. To get the credit score, customer will try to understand whether giving this loan will be safe to the customer, because somebody is not repaying the loan is a loss, huge loss for that particular bank, right? So they'll use these machine learning models to analyze. This will be something like a binary classifier, which will tell me whether the loan would be given to that person, or he'll be denied, right? So something like binary classification model will work there. Similarly, the other one is that investment. Banks has different types of investment instrument, like different types of market link plan, flexi plan, which is it depends on the ups and downs of different shares um, in the share market, right? So therefore, bank has its dedicated managers who actually create a portfolio of those different companies, and then they invest there. Okay, so therefore, if you are looking for an investment plan, you want to grow your money, they will offer you those products. Okay, but here also, all these market linked plans have this common problem that there is no guarantee, right? If you're depositing your money in a savings account, you know that at the end of the year you are getting 4% interest on that. That is guaranteed. But all these market link plans are not guaranteed. So therefore, bank has to take some decisions about whatever investment portfolio they have created. What is the risk in that? Okay, what is the risk, and what is the likelihood? What is the chance that this will grow by more than 10% in the next year? So they have to do this kind of investment risk modeling, and there also they are very actively they're using different types of machine learning models. Recommendation is also one of those everywhere, not just in banking, retail, everywhere. Recommendation engines are actually now working. Okay, and now depending on your search history, or transaction history, or profile data, can analyze this information to make better type of product recommendations. For example, um, let's say you are using a credit card, okay, and you're using the silver credit card, for example, and then your spending for last couple of months is you're spending a lot, right, through your credit card. So just by looking at this particular transaction history, the bank will offer you a better version of that particular card. It will say that, let us now we'll offer you as a premium customer, we offer you a gold card, or a platinum card, okay, and then they will increase your credit limit and so on. So everything now, these systems are getting automated. There is no human sitting there who is actually observing each customer's entry. This is not possible at all, right? So they are actually using machine learning models that actually generate this kind of flag that, okay, this should be the next step, this next kind of offering that we can give this to this particular customer. Okay, so this kind of recommendation engines are being used very actively in banking nowadays. The other important factor for not just banking, for any company should be this, what is the lifetime of the customer with that particular company? Okay, so what you call as CLV, or customer lifetime value. So if customer is actually holding an account with a particular bank for a long time, so then the chances of having better revenue generation actually increases for that bank. So you can actually model those customer as follows. You can simple a Gaussian distribution. There are some customers who are more active and more profitable. Maybe the 60% customers are belonging to that group. There are some customers who are non-profitable, and then banks shouldn't spend their advertisement. Every advertisement, you're getting a call from the customer care team. Everything is so expensive, right? So therefore, we should actually find out that who are the customers who are more profitable to me. Okay, and there could be a small group of customers who are extremely profitable to the banking business. They're very proactive customers. Maybe someone who has started a business, for example. So we'll actually open new account, and business transactions are normally of huge amount, and number of transactions are also very more frequent, right? Therefore, if we are able to predict this customer lifetime value, um, this will be helpful for that particular business. Okay, not just in banking, but I'm just taking this example of banking in this case. Um, Other important aspect is any kind of financial fraud. Okay, and this specifically a problem in banking, because doesn't matter what type of business it is. Every time any kind of online transactions, there is some sort of payment gateway or bank is involved. Okay, so if there is any fraud in kind of authentication or transaction, ultimately the bank is somehow responsible. Okay, so so let's say you are using a credit card for making an online transaction. Okay, and somebody actually steals this sensitive information of your credit card and misuses it. So that could be one type of financial fraud. The other could be something like somebody is actually pretending to be you, right? So they are not, but and they want to perform certain transactions on your account. So bank believes that it is you, but it is not you, it is somebody else, okay, with some malicious intention. So in this case also, we use machine learning algorithms heavily, which traces, the pattern of the, previous history, right? So, and then there are, different tools that are actually integrated with business software to keep track of customers' transaction and past histories. Okay, and that actually help us understand, if any transaction going on, which is, which is not matching the previous pattern of that particular customer. Okay, and therefore that transaction can be, stopped in the midway, or maybe, we are before, there is huge financial loss. Okay, and this kind of, machine learning models are actually significantly actually brought down this number of credit card frauds over past 5 years. Okay, so they are very successful because, any kind of, financial transaction, especially, this transaction with huge amount of money, and banks actually loses lots of money if they are not able to track it properly. So this is one of the use cases where, they're using data science, machine learning to automate, and solve this problem. Personalized service, I already given lots of examples of this. Okay? Looking at your frequent transaction, shopping history, repaying of loans or bank balance, they generate your credit score, and then we identify profit generating customers so that, better, personalized services could be offered to them. And we can also, some other offers, for example, some promo code, discount coupons, or maybe some policies, for example, that should be, offered, or any kind of, customer loyalty program. So those are different instruments that banks are actually using. The other example, very quickly, I would like to give here, is this, example of retail analytics. So in retail, um, we have, different types of machine learning algorithms are being used. Okay, so we'll see here, if we are talking about, what should be the right kind of pricing for a particular model, that is called pricing analytics, and then we talk about different optimization techniques there. Okay, if we are talking about, customer analytics, for example, segmenting customers into, looking at their purchase and, purchase behavior, for example. Okay, or demand forecasting is another very big issue in retail, because what type of, uh, products or which brands, our customers are favoring, accordingly they have to, procure those brands, and then they have to inform their supply chain so that, if somebody, the customer is going to the retail shop, is not getting the brand that they're looking for, they will actually move to some other place, right? So therefore, this demand forecasting, and we have this multivariate time series and different types of models are there, uh, which is actually very successfully, solving these problems. Okay. Um, and customer churn prediction, I have already mentioned it. I'll not repeat it. Recommendation engine, purchasing product X, and I'm giving you some other product as recommendation. So I'm going to purchase a mobile phone. Along with this, it's giving me, what type of, mobile adapter I need, or maybe a screen protector, or maybe the mobile back cover, and so on. Similarly, other important aspect in this digital analytics is this cross-selling and upselling. Okay, so you're buying a product. I buy something like, mobile phone, and I'm giving you this, mobile adapter as, that's basically example of, cross-selling. Or maybe upselling with something like you are looking for a mobile phone of certain specification, but, we are providing you, we are encouraging you to purchase a higher configuration, more advanced version of that mobile, and we are, you are encouraged to spend more money on that. Okay, so those are actually market-based analysis, uh, and collaborative filtering, content-based, recommendation engine. Lots of different types of algorithms are there. The other type of algorithm that I would like to mention here is that sometimes those retail shops actually optimize their uh, in-store shelves depending on the requirement of the customers. So for example, if you are buying a bread, so there is high chance that you will also buy a milk, right? So therefore, if I keep those shelf which contains milk uh, and bread close by, and then there are chances that somebody is really getting, without actually, roaming around all around the store, right? So therefore, they're getting at nearby place. So that kind of, optimization can also be done. So you see that there are lots of examples, but I don't have time to talk about all of them. So I briefly touched upon them. Other use case I'd like to talk about is in this domain of manufacturing. Uh, Probably less taught maybe, right? So this is called predictive maintenance. So in predictive maintenance, what we actually do here is that in any company, for example, any manufacturing company, they're using big machines, right? And we need to sometimes that those machines actually need some maintenance, periodic maintenance time to time. Okay? So if you can use these machine learning models to predict when this machine will fail, and then before it fails we can actually uh, have schedule our maintenance, right? So therefore our risk actually reduces, right? And therefore our impact on final production actually is reduced by a large amount. Okay? So this will actually improve maybe the cost efficiency and subsequent cost of maintenance repair. We can optimize the asset availability. We can lower our risk. Okay, and then eventually that will help us to generate better revenue because the machine works for a longer period of time. I don't have to invest more money on that, and therefore business will actually make huge profit out of it. Okay, so in this diagram I try to make you understand this. Here we are actually computing something called overall equipment effectiveness. Okay, so if we are maintaining that particular machinery in a reactive basis, so reactive means when we'll keep using it until it breaks down, and then when it is broken, then we'll actually schedule the maintenance. Okay, and then we see that our overall equipment effectiveness is less than 50% in that case. Okay, but if it is planned, if it is proactive, it is predictive, then gradually our effective equipment effectiveness is actually increasing, right? So you'll see that with this kind of predictive maintenance machine learning models, which will predict when it's actually bound to fail, and therefore before that looking at my requirement of that machine, how much it's contributing to the production, we can actually do those maintenance. So in my next slide, I'll try to explain it. Maybe so here you see that you try to understand this. Sorry. So you're basically collecting this information through lots of industrial sensors, and that information is now we are using some machine learning model to make optimized decisions. So here we see that we have this number of days remaining life of that, and then when there is some part where our production is at high peak, but at some point if I schedule it on that particular days, my production will be impacted lesser. Okay, and therefore that means the business will be able to make more profit if it is the machine is off on those days rather than other days where the productivity is very high. So here's a nice example of that. And normally, as I told you that my data science is possible only we have data. So you have to collect more and more amount of data. And now with IoT devices, IoT sensors, we are basically collecting this data, around the clock. Okay? Huge amount of data being collected. And subsequently those are actually stored in some data lake, cloud-based storage. Uh, Subsequently, we'll apply some machine learning algorithms on it, to extract meaningful information. We perform data analytics, and this step is, uh, there is of course, some maintenance steps also. But if we talk about some specific use cases, right? So then we see that this kind of sensors are, and data science, machine learning is heavily used in oil and gas companies. For example, in this case, we see that, pipeline where, there are different sensors which is placed there, which is actually, measuring lots of, important parameters like, what is the pH amount, what is the amount of carbon dioxide, hydrogen sulfide in that pipeline, maybe some other factors like what is the pipeline diameter, thickness, and so on. And given this data is actually stored on a cloud-based system, which runs some pre-trained machine learning models, okay, and analyzes this data and makes certain predictions. Okay, what are those predictions? These predictions are maybe somehow, what is the pH or carbon dioxide level, and if it is, beyond a certain threshold, right? So then that the chances of, this pipeline getting damaged is more, right? So therefore, looking at this particular, visualization or alert message, the operator can actually, may take certain decisions like, shutting it down for some time and so on. The other example could be, this example of railways, where different sensors are actually placed on the railroads, which actually measure whether there is some unhealthy pattern in the sense of, what is the excessive load is there on the rails, then the chances of breakage actually increases, right? So can use again machine learning models, data science, cloud hosted data science models, which will do this analytics and then give us, what is the probability of the train breakage now. Okay. So operator can actually take decisions on that. Maybe unload certain carriage or maybe stop that particular train there and then take corrective measures. One of the specific use cases, I have found here is this, BNSF. BNSF is one of the largest freight carriers in North America. They are actually using this kind of systems, and these images, they have vision-based systems like cameras. They have other type of sensors, thermal sensor, acoustic sensors, force sensors, which is continuously, monitoring this uh, data. And then there are, machine learning-based models, which ensures that, all these, industrial scale solutions is actually improving the reliability and availability of their systems to their customers and employees. What are the benefits of predictive maintenance? I've just listed down here. I hope that by now you have understood it. Reduced maintenance time, fewer machine failures means more productivity. More productivity means, more number of, more number of, output. Throughput is better and therefore better revenue. Increased production time, shortened operators, heightened operator safety, verification repair cost will be minimized, profit increases, ultimately a goal in every business. I'll end this presentation with this discussion on healthcare. And in healthcare domain also, this is an extremely, you know, important area where, data science can revolutionize this entire healthcare system in terms of maybe some predictive analytics, image analysis, genomics, drug discovery, um, and after COVID, we have understood the importance of drug discovery and vaccination, right? So therefore, extremely important field. And data science, machine learning have been used here very successfully. Okay. I've taken this example of medical image analysis here, and we know that we collect images, not just by optical cameras like our mobile phone. When it comes to medical imaging, we talk about many other modalities like MRI, X-ray, CT scan, and so on. Okay. And all those radiology images, given to a radiologist, which is a human being. So there's a huge demand for these radiologists in the market. But over the past few years, we have been able to create many machine learning and deep learning based systems which can perform this, detection task with better accuracy than any experienced radiologist. Okay, so whether it is an MRI, we are talking about any tumor, what is the progression of this tumor, or maybe a fracture in your bone, and whether it is so minute that is X-ray is not able to reveal it properly, but our pre-trained deep learning models will actually work on that. Fantastic results. Okay, and the accuracy is many times better than the accuracy of very good radiologists. Okay, so therefore we see that there is a huge potential. This will not only save human lives, this will save human hours, right? And then scope is very huge and very successful. All these models are very successful. The other important aspect here is in healthcare we talk about uh, we are using this data science for medical imaging. One example I have already talked about, some sort of providing some visual assistance, right, to a patient. So we are tracking and preventing diseases. Okay? So if somebody is using mobile app, for example, other examples are basically there's a complete new field which has been generated, like data science for genomics. Okay? So you want to understand the genome, genetic code, genetic pattern to understand the disease in a better way. And drug discovery is another another field, and all our objective here is that we can give better monitoring, better personalized care to the patients. Okay, that's basically the objective. Because every drug, some there are some drugs which is tested for a long time. Like if I have fever, I'll take a paracetamol, and paracetamol works fine for everybody, right? But whenever you take a drug, there is some sort of biochemical reaction going on inside our body, right? And now every human being is different, and then their genetic code is different. So if we are not testing a drug for a long time, then there is a possibility that one drug is working for me, but it will not work for you. Okay, because of those inherent difference in our genetic code. So that's why our objective is to give personalized medicine. If I am able to dig this information out, that okay, this is the genetic code, and for this particular person this type of medicine will work best, then we can provide this personalized medicine rather than testing on some general medicine which works for everybody. And it's also extremely time consuming task. So, so therefore, this domain of genomics and data science, genetics and genomics, try to understand the genetic code, and this genetic mapping is very important, uh, because if we understand this properly, we understand the progression of a disease inside the human body, and therefore, personalized medicine could be provided to them. And this drug development is another fantastic area, where which is has lots of scope, right? Because billions of dollars are being spent here. And during COVID time, we have understood that we know these companies who have created the vaccine, but now that is not tested properly. We had this long time to get the medicine out, right? So you had to wait for almost 2 years to get that particular medicine, even though that was in line in that process of discovery for a long time. So therefore, drug development is a very time-consuming process. So normally 10 to 12 years they need to test on in the lab, right? Lots of clinical testing. Only then they get certified by the approving authorities. Okay. So and now here what we are doing here is that in drug discovery and data science especially, what we do here is that we create computational models. Okay, rather than mixing two chemicals in the lab, what we can do, every reaction is biochemical reaction, right? So therefore, at the lowest level, there are some molecules, which is actually making some chemical bond together, right? So if you can build computational models, okay, which is actually telling me that this molecule with that particular substance will make this kind of bonding inside a human body. Okay, and there are there are there are millions and billions of such possibilities. Okay, number is very huge, right? And that's basically the complexity of the problem is very huge. Okay, But we can build our computational model now because we have high performance GPU, we have cloud sources available, we have parallel computing is available, right? So you can build such computational models, and in a very short period of time, we can perform thousands and millions of uh, simulations, and then we can actually use this data for a much faster drug discovery. Okay? So this idea behind this, this is called computational drug discovery, and it's actually creating computational models to simulate this biological, it's actually simulating human biological network inside a computer. Okay, and trying to predict what will happen if this drug is provided to this human body. Okay, so extremely important field, not from the perspective of profitability of a pharmaceutical company, but in terms of its benefit to the mankind as a whole, right? This computational drug discovery is extremely important field, and extremely important and recent field where data science is actually contributing hugely. Um, the other example, with which I'll conclude this presentation is this virtual assistants. Okay, so nowadays we use smartphones and all these smart apps, which we can continuously interact with those. Patients are interacting with their mobile phones, and then they are being suggested that okay, this is the time you have to take this medicine, for example, uh, or maybe we have chatbot services for better customer support. So somebody wants to have an appointment with the doctor, you can actually use this chatbot service, rather than involving any human operator there. Okay, so these things are there, better medication, better health, better lifestyle, which will remind you when to take your medicine and so on. So all these, data science based, AI based, machine learning based virtual assistants are actually improving the customer support and patients' life. Okay, and both patients and doctors, right? All right. So I'll stop now. This is the end of this presentation, and I would like to invite questions now, or maybe Edvancer actually can talk about their programs, and after that we can also invite questions if that is required.
Right. Thank you, Dr. Saurabh. I think we'll go ahead and talk a little about Advancer and the courses that we offer so that
Right.
I think a lot of people
Yeah.
might be interested in about their career in data science and whether it makes sense to move from whatever domain they're part of right now, and in what way they can do that. And in addition to different ideas and use cases that you've discussed, I think we'll have a good overlap of questions then. So let me, hey everyone, I'm Lalit. Let me quickly talk about what we do at Advancer and then what kind of different courses that we offer. And we can, of course, discuss, what aligns with what you're looking for. And it doesn't have to be that you want to do one of those courses. The questions can be in general about your queries regarding to ML data science and so on. All right. Just give me a moment, a couple of settings, and then I'll start. Okay. Is my screen visible to everyone? Am I audible properly? Just a quick check.
Yes, Lalit, you are.
Okay, cool.
Yes. Yes.
So I'll begin the discussion with talking about what Advancer is, and then we'll come to the part that probably you have been waiting for is what kind of courses we offer and aligns with your domain, be it education or where you're working and so on. At Advancer, we have been it's been almost a decade since we have been providing machine learning, data science training consultation to both individuals and industry professionals. We very recently became part of global university systems, a global education house spanning across continents, having presence in Canada, Australia, Europe, in addition to having multiple institutions in India across almost all academic and technical domains, be it fashion, be it machine learning, be it mechanical engineering or petroleum engineering. Many different institutions that they own and operate. Uh, and Within Advancer, our team over the years, when we were independently working, and since we have been part of GUS, we have trained almost more than 10,000 individuals in a decade, and 100 plus organizations that we routinely train at. And we have seen how the field has evolved. Uh, a decade back, it was like starting at something being very niche to finance and healthcare and making its headway to other domains. And now we are in a situation where it is, in fact, very difficult to find a brand or a company which is not making use of data in some or the other way with the statistics and other tools that we teach, which I think must be very evident by now with the very informative sessions that Dr. Sorab just walked us through. In fact, we see domains as niche as fashion and breweries, wineries, having ML as one of their core business functions. Uh, and In order to facilitate now data science and machine learning training across such a diverse set of businesses, we routinely partner with premier institutions, both locally and globally, and online, such as IT Kanpur in India. We have other upcoming partnerships, but we can't really talk about it as and when it officially happens. London School of Business and Finance in UK, Coursera, Edology, IBM, that we partner with for many of online courses that we have. And apart from just listing down these things for you, if you want to know what probably is not there on the slide is the kind of value which we bring as training partner to your success has been time and again acknowledged by many independent reviewers. For example, if you want to look at what individuals have to say about us, you can quickly go on Google and search for advanced reviews and see for yourself. And these are the reviews that you know we don't really have any control over. This is what people have actually experienced and what they're writing about. You can also look at renowned analytics voices in Indian media that we have and globally so, such as Analytics India magazine or Analytics Vidya, among many others, and see for yourself what they have to say about us. I have a question. I'm a BBA graduate class of 2014. Just hold on. 6+ years of experience in investment banking operations, AML, KYC, totally from non-tech background. How challenging will it be for me to complete this course with 90% and plus score also? So Prashant, I think I'm missing a part of your question beyond also, but I get what you're trying to say. And I think if I answer that question in context of the actual courses that we offer, I think then you will have a better perspective, and then probably we can take this question. Okay, so just hold on for a couple of minutes. Okay, coming to the kind of courses that we offer, and they cater to, just a moment, different, as I said, that people come from technical, non-technical background, freshers, people trying to make their headway, people trying to have been working in industry for some time and trying to switch to their career, or trying to bridge the gap between what AIML is doing and what they are doing without really having to leave what they're doing. So people come with different backgrounds, different motivations to ML, data science, analytics in general. So we have different flavors of courses, starting with this advanced certification in AI and ML, which we offer in partnership with IT Kanpur. You get the certification from IT Kanpur, and the many sessions which are conducted by faculties coming from IT Kanpur. uh, and the content, etc., has been curated and approved by them. So this is aimed at people coming from technical background, who are, if not already having experience, okay with ideas about programming. This majorly starts with technical discussion on Python and machine learning, goes into deep learning and AI technologies, in addition to uh, working with quick data querying tools such as SQL. And as all of our courses are, it contains good amount of online learning and hands-on assignments and so on. But these aspects we will, I'm going to keep for later. Why Edvancer, what differentiators. Right now, I quickly want to walk you through what kind of people different courses uh, caters to, what kind of groups whose demand these different courses cater to. So this AIML certification in AIML is targeted towards people with technical background or somebody who's interested in it. Somehow I find the term that I'm from a technical background, non-technical background, science, kind of fluid. Now you're from non-technical background. God knows when your interest, you might get interested in something and you start to learn. But anyways, I understand where you're coming from. Now, the next bit course is targeted towards, or actually made for, people who come from non-technical background, where programming per se, to begin with, something which seems challenging or you're unwilling to do. So the tool that we use, we teach business analytics, and the idea here is that as we discussed, that now usage of data and statistical techniques are making their headway into all the domains, all businesses. It's not just finance or healthcare or banks. It's now everywhere, in fashion, manufacturing, wineries and whatnot, beverages, FMCG. Everywhere people have data, and they are making use of these data analytics tools. And so the particular tool R that we teach in here is a tool written for statisticians, and statisticians are not programmers. Okay, I would say R is a kind of open source alternative of Excel to begin with. But of course, it has, as we progress in the course, you realize that it can do much more. Uh, Maybe comparison to Excel is not that fair, but to begin with, just to make this drive this point home, that it's very different from a typical programming language, what you might have had exposure to in your college, and since then you have developed some kind of uh, I would say you don't like when you hear what programming languages are. So it's very different from there. And it's a tool of choice for many people who come from domains like academic domains, like humanities and arts and philosophy, which overlap largely with statistics, and they use R. We do talk about data querying tool, SQL, and data visualization. So this course as a whole focuses more from the business perspective, storytelling with your data, basic analysis of data, and basic regression modeling. It doesn't go into a very technical, deep learning or very core optimization ML techniques. So this is where you begin with, if you want to start your career in data analytics and you're a little um, uh, apprehensive about that, okay, this might not be my cup of tea. This is where you should start. Then we have a more uh, I would say a comprehensive program that is offered by UPS in partnership with UPS. We bring in, so here is where you haven't been part of data science per se. You want to begin, but you eventually want to graduate to next level also. You don't want to you're starting your career, or you completely want to switch into data science. So beginning with the predictive analytics in R is a good place to start, and then you can go a step further. that is working with machine learning in Python, data analytics in SQL, and then we have a couple of domain specializations available with as part of the program. Then we have certified artificial intelligence specialist. Again, this is a larger program, bringing in multiple different courses where you can start with predictive analytics, and you can then go to data science, ML with Python, and up to the level of AI and deep learning, along with, of course, the storytelling and data querying program, that is Tableau and SQL. So this is one of the very comprehensive program. Then we have data analytics specialist program, but this was being offered in participation with IIT Kanpur. This is a similar program, just that it might be a little more cost effective, coming that that premier institution partnership isn't there. So if you're just interested in learning about things and maybe not the name of an institution, then this program could be for you. Although if you're trying to make a headway, my personal suggestion will be to go with ITK program, but this option we have also kept because some people ask for that. And so you will find these offering elsewhere also, to be honest. Uh, more and more different institutions are kind of offering same or similar things, at least the face of at the face of it. What differentiates Advancer is we have this course curriculum that we deliver is not written or developed from academic perspective. So we routinely deliver these programs to industry organizations like ENY, Deloitte, uh, General Mills, GE Caps, and so on. So across different banks and manufacturing companies and consulting companies and so on, from very diverse domains. And this is the same curriculum that we bring to the classroom at Advancer. So it's very tuned with what is happening in industry. It's not something that we developed, say, 10 years back or 5 years back, and we have kind of been shelling the same thing. It's not like that. In fact, month on month, everything gets updated, as it's a very fast moving domain industry as such, and we need to be updated because we are actually delivering the same content to people working in industry. So and the next thing is that it brings in a lot of hands-on uh, content to it. You actually work with data and solve problems and case studies which are in a spirit very close to the way you will develop projects in industry eventually. Of course, that doesn't mean from the get-go, from day one, you start working on projects which are similar to industry. We start slowly, get your feet wet, and then by the end of the course, we ensure that you can hit the road running. And there are, so as the focus, you can see focus is on a hands-on practice. There are many projects. So every course in the program comes with multiple projects for you to work on, and we don't believe in the fact that you pay us and we give you the certification. You actually need to uh, work hard, and of course we are there to hold your hands to for completing the course every step of the way. But yeah, you need to work hard and complete some projects to completion. You work on projects to completion in order to get the certification, and that is what has generated the kind of power advanced certification holds now, because we are not handing out certifications just like that. So it comes with a certain value in industry. And when you complete that and we help you in completing these courses, we give you placement assistance, and which lasts as long as you get the job. There is no time limit that, we'll assist you for 3 months and then you're on your own. Until you get a job, we'll keep on assisting you. We'll keep on sharing um, opportunities with you. We'll keep on doing mock interviews with you. We'll keep on helping you with being updated to your skill set and anything additional that you need. The kind of faculties that we bring in are a combination of people who have good academic background in addition to industry experience. So that whatever they're teaching or talking about brings in their actual experience on the job, as well as the academic rigor which you would need or require, or you would want to have in order to getting started with any domain, so that you learn the basics as well as you know how those basics actually solve problem on the ground. And that is what we look for in our instructors, who can facilitate that for you. In addition, the content, be it the lectures that you watch, or the case studies that you work on, or the presentations, or the data, or the scripts, you have access to them 24/7 for life once you enrolled into our program. There is no time limit, which you'll find in tons of other courses that you will see online. And so we have students who, even the ones who took our courses 7 8 years back, and the industry has changed drastically since then. There are newer tools being used, and they have been updated to a good extent, so they keep on coming back and they get access to updated content. So once you've taken the course, it is something that you keep on coming back to. It's not like, okay, you have to do this all over again, say 2 years down the line. No, not really. You can come back to and get access to the same updated content all over again. This becomes a reference that you come back to uh, in your data science career journey. The companies, we had to pick some of them, and among hundreds of companies that we partner with, these are a couple of companies that our students routinely get placed or have been placed at. These are also the companies that many of them where we do conduct training sessions for their employees, or have conducted a couple of times in the past. And I think that is where the relationship started, and now they reach out to us for uh, uh, ML and data analytics resources, and we send across the same opportunities, share the same opportunities with you, and then work with you in order to for you to convert those opportunities. We are not so here I would like to state this explicitly. We are not one of those institutions who would want to lure you with saying that we offer job guarantees. I don't think anybody can, and whoever is telling you that there is job guarantee, there must be a catch. And so what we do guarantee, that we keep on sharing these opportunities with you. Converting them is up to you. So we'll do as much as hand holding we can, but giving the interviews and converting the interviews, being the best fit for the job from the employer's perspective, is something that the last leg in that journey must be yours to convert. And we know that there are failures at the beginning. We have seen that happening, and we are okay with that. That is where we come in and say that, what, the we will keep on assisting you until you get a job. And I think that's a very realistic promise that we make, and we stick to that. Okay, so there is that, and these are the kind of brands or opportunities that you will have access to. Just to talk about numbers, and uh, these are, I would say, slightly older numbers. We have grown beyond this in scale since we have become part of global university systems. So yeah, you will get access to now something better than this. Every month we have 12 to 15 opportunities sent across. That doesn't mean 12 to 15 jobs. It means 12 to 15 companies reaching out to us, and each one of them must be hiring anywhere between 1 2 to 5, or even 10 people. 10 is something which happens rarely, but yeah, any of these opportunities will be aimed at couple of people, and which results into many interviews being scheduled. And these are the interviews, these interview schedules, whoever requires that, what, I would want to have a mock interview before this, or I want brush up ideas, or why don't you check where the gaps in my understandings are. We do that before these interviews happen, if you require. And this leads to roughly 10 to 15 students being placed every month. And as I said, these are slightly older figures pre our involvement with Gus. Since then, we have grown in scale, and these numbers definitely have gone up. And so I hope I have answered many of your questions already. And if I haven't, feel free to reiterate them. Prashant, I would address to what you're asking now. So you're totally from non-tech background. How challenging will it be for me to complete this course with 90% and plus score? So I'll address this first. So the scoring, be it 90% or 85%, I believe and that is what we implement also. It's a very academic idea. Our focus is more on, if given an analytics project or machine learning project, can you see it to completion, even if it requires some bit of handholding. So from a completion perspective, there are multiple projects that you choose from in every course. So if a program has 4 courses, you will have a couple of projects in each one of them. You need to complete those projects in order to get the certification for that particular course and then for the entire program. So it's like completion of projects in itself is a good learning process, and once you complete them, it's like you are there 100%. And unless you haven't completed them, you are at zero. So this might seem a little harsh that you're either zero or one, but this approach has essentially works beneficially. You have benefits people in learning. You have multiple attempts available. It's not a one-time exam that you do. So we are move you know we are done away from the academic framework of completing a course. It's essentially the way you will learn things on the job. It's not that tomorrow you have an exam and then the next day you either have a job or not. You learn thing on the job, and eventually with some time you get better at it, and then you move up in the organization. And the the learning or the teaching follows the similar idea here. So yes, you need to complete a course, and once you complete it, you have 100% learned what we intended you to learn. So that is there. There is no uh, 90%, 85%. Addressing the non-technical background thing, I think so. There are programs geared especially towards people who are coming from non-technical background, so that should address that. And we can go into detail of that if you want. Regarding placement support, how likely am I going to get placed, as the companies will prefer a fresher rather than an experienced guy? uh okay, that's kind of a misnomer that that companies will prefer a fresher. More so, yes. I think this perception comes from that there are going to be more opportunities at lower level in the pyramid, of course. So there will be much more entry positions available than somebody at a certain higher level with as a product manager or a team lead and so on. So that's going to be there. That doesn't so and then that comparison should happen with other jobs also. And from that perspective, I don't really see a difference. And coming to that, they will rather prefer, or they not will, they do rather prefer somebody who's fresh in comparison to somebody who's coming from having experience in a non ML background. ML is not a new domain per se, right? It's a tool to solve business problems. And to solve a business problem, it's not that ML and now you enter somewhere and you'll start solving business problem right and left. It will require certain business acumen, the domain understanding of things. So with certain amount of experience, the kind of positions that you look for, which comes at the intersection of what you have been working and having the ML and analytics knowledge. Okay, and I don't think that is something that a fresher can provide who's just out of college, just graduated. And there are decent opportunities, good number, and of course comes at a much higher remuneration and the kind of responsibilities that you uh, get to work on, or so on. I hope that answers your question, Prashant. We can have a very detailed one-on-one conversation also. You can reach out to us here at info@advancer.in. You could give us a call. And if you're in Mumbai, you can drop into our Mumbai office also. Any other questions? Anyone? I hope I answer your questions, Prashant. And if anything remains, feel free to let me know. You will be receiving more details as brochure for the programs and courses. And if you're interested, we'll definitely would like to follow up. And when I say interested, it's not just you're interested in our course. You just want to have you are curious at this point. You have heard about data analytics, machine learning. You have heard your colleagues talking about. You've read some articles, and you're curious. You want to explore. You want to know more. We are open to the discussion. Okay, whatever queries that we can answer. If not here, then personally. Do you have any data on how many non-tech people who have completed the course got placed from the last batch? Uh, well, I personally will not have those numbers on my fingers just now. So we can definitely provide data for different groups, for different backgrounds. Just drop us a mail. Yeah, we won't mind sharing that. An approximate idea will do. So in every batch, say if we have batch size of 35 to 40, there are roughly 5 to 6. The number varies, 5 to 6 or 10 to 12 people who join from non-tech background. And among them, many of them are there for learning. So let's say 6 people are joining. Not everybody is looking for a job. Somebody is exploring, somebody just wants to learn, and then try to bridge a gap themselves. So among 5 to 6 people, 2 to 3 are the ones that we end up placing from our end. It could be a job switch or getting starting with a career. And rest of them are so there are a couple of people also who end up not completing the course. That happens. And then there are some who have a different motivation to join the course to begin with. Yeah. And this number can vary highly depending upon how many people from non-tech background are actually joining the batch. So that number varies. In some cases, in every batch, there it could be 2, 3 that they get placed. There might be batches where nobody get placed. There might be batches where 4 or 5 are getting placed from non-tech background. Cool. Okay. Uh, any other questions that I can cater to? And if not here, as I've already mentioned, that you can reach out to us separately over the email or call. You can actually drop in our office. Okay, then. Thank you, everyone. I'll for a last call for any queries. If not, we'll call it a day. I'll wait for a minute. And if you don't have any questions, feel free to go. Thank you again, Dr. Saurabh, for joining us, for walking us
Thank
through such
you.
an informative session. Thank you,
Thank you.
everyone. Thank you for your patience. Thank you for being with us. I'll call it a day now, and I'll repeat. Sorry for repeating so many times. If you still have any queries which you would want to get answered, the contacts are right in front of you. Do make use of them. Thank you so much. Bye-bye. So I'll give you a
Thank you
moment
very much.
to note these down if you want, and then we'll close in a moment. I'm going to mute myself. Thank you. Bye-bye. Hey Jyoti, I'm so sorry. Yeah, we haven't been able to listen to you if you're saying something. You could, yeah, I mean, if you could have mentioned the issue that you're facing earlier. You could still drop what you want to ask in questions or drop us a mail if you're still there. Just a moment. Yeah, I can see your messages. Hi Jyoti. Yeah, but I'm not able to. Hold on. Could you try speaking now? I see that you're muted. If you're using any mic, or you could always put your message in the question of the chat box. You want to work on projects only. Uh, okay. I don't think we have that kind of offering that you directly join the course and simply work on the project and get the certification. No. Generally, what happens that unless until you have been through a comprehensive course, there is a lot more to learn in the course. Yeah. So I have knowledge of some tools. So it's okay. The courses are it's it's not just about the tools. It's not just about the mathematical idea. It's not just about how things work in industry and what kind of challenges that you might face when you actually work on a project in industry. It's about everything brought together. And even if you are working as an analytics professional, there is a lot to learn from the course still, which you might not be aware right now, and you'll realize once you do the course. So as the same content is delivered to people who are actually working as data scientists or similar roles in industry. So it's not that because they're working there already, they know everything. There's a lot to learn still for them. And I'm sure there'll be, although I'm not aware exactly, where you're working or what your academic background is. So I won't be able to comment on what you already know, but empirically, I've seen that there is a lot to learn for everyone, and you might realize that once you actually do the course. So a short answer to your question, no, we don't have an offering where you just work on projects. And that said, there's still a lot to learn, even if you have a background in math. Can I call you on WhatsApp, same number? I do have a session to take starting at 2. So maybe after, oh yeah, this number will connect you with our team advancer. Yes, you can reach out to us right away. To me personally, you can ask them for my number. I'm Lalit Sachan, and they will connect you with me, but I'm not available until 5 today. I have a training sessions to take from 2 to 5. What is the fee of this? These logistics details, the fee and the schedule and the size and other logistics. I think once you drop us a mail, we'll reach out to you and share all the details. The fee varies for different courses and customization. So Anurag, if you are coming from an engineering background, a comprehensive course for you will be uh, this. If that is something that you want, that you're beginning with your learning and you would want, since you're getting started, many people come with the thought that, you know what, if I'm getting started with this, why not do till the end, cover everything. So that's the one for you. And if not that, you want to take it slow, then this will be a good place to start. Okay, so either it is my suggestion to you, and I think we'll know more once we discuss things personally one-on-one. But just with the engineering background, my suggestion will be if you want to take it a little slow, advanced certification in AI/ML, and if you want to learn in a more comprehensive way, then certified artificial intelligence specialist program is for you. Okay. Any other queries, anyone? Cool. Okay, let's call it a day, everyone. You know how to reach out to us, and we can continue this conversation. This doesn't have to be the end. See you there. Bye bye.